Hello there. Welcome to section 3 of Unit 4. In this section, we'll be looking at X-rays. Let's look at the objectives of this section. The first objective is to learn what an X-ray is, know how X-rays are produced, and know the applications of X-ray. X-rays are produced when rapidly moving electrons that have been accelerated through a potential difference of an order of 10 raised to the power 3 to 10 raised to the power 6 volts are allowed to strike on a metal target. X-rays are also produced in a highly evacuated glass bulb called the X-ray tube that contains essentially two electrodes, that is, an anode and a cathode. So the heated filament emits electrons by what we call the thermionic emission. A thermionic emission is the flow of charges or charged particles called the thermions from a charged metal or a charged metal oxide surface caused by a thermal vibration energy overcoming the electrostatic force holding the electrons on the surface. There are three basic components in this X-ray equipment. One is the X-ray tube, one low voltage power supply, that's our electrical source, and one high voltage supply. The vacuum tube uses a high voltage to accelerate the electrons released by the hot cathode to a high voltage. The high voltage electrons collide with the metal, that's the anode, and that's creating the X-rays. There are some conditions that needs to be considered in the production of X-rays, and one is that there is a beam of electrons moving at a very high speed, that is from the cathode, and two, there is a proper target which is to be a barrier to stop the motion of the electrons, and that is our anode, and changes the kinetic energy of the electrons into an energy of what? X-rays. We can actually measure the hardness of X-ray. So for here, we are going to learn the intensity and hardness of X-rays. When we say the intensity of X-rays, it is defined as the energy of X-rays passing through a unit area with normal line along the propagating direction of X-rays per unit time. So here, the intensity of X-ray is defined as, the formula mathematically is defined as the summation of the number of photons times the Planck's constant times the frequency. So here, depending on the number of photons that you have, we do a summation of it and we multiply by the Planck's constant and the frequency. When we say the hardness of an X-ray, we just want to know the penetrating ability or power. And this depends on one, the wavelength of the X-rays and the number of X-ray photons. The hardness of X-rays energy can be hard or what? Soft. It actually depends on the wavelength of the X-rays, not the number of X-ray photons. The hardness of X-ray is always proportional to the energy of X-ray photons. It is known that the energy of X-ray photons is proportional to the voltage applied to the X-ray tube. Therefore, the hardness of X-ray is usually expressed in tube voltage in kilovolts. Let's look at the applications of X-rays. Most applications of X-rays are based on its ability to pass through matter. This ability varies with different substances. Example, let's say a wood, a flesh, a tissue, they are all easily to be penetrated as compared to a denser substances such as a lead, a bones, they are all very opaque. X-ray that have passed through a body provide a visual image of its interior structure when they strike through a photographic plate or a fluorescent screen. The darkness of the shadow produced on the plate or the screen depends on the relative opacity of different parts of the body. Hard X-ray is normally used in airports so that they can use it to do what? For security checks. And soft X-rays are mostly used in medical purposes. X-ray too can be used in heavy industries, medical treatment, even in food analysis, in electronics inspection, in pharmaceutical companies, and others.